Good morning, students. Today we are going to discuss two important topics from chapter 7. And the chapter 7 is your alternating current. Now the topic which we are going to discuss, first topic is your mean value of AC or mean value of alternating current. So before going to the mathematical part, let me read out what we have written. Mean value of alternating current is that value of steady current which sends the same amount of charge through a circuit in a certain time interval as is sent by an alternating current through the same circuit in half cycle. Let me repeat once again. Mean value of alternating current is that value of steady current. Is that value of steady current means the formula for steady current we are going to apply, which sends the same amount of charge. For steady current, what is the formula for current and charge? Current equal to charge by time, is not it? Rate of flow of charge is nothing but the current through a circuit in a certain time interval, and the time interval is given here, half of the cycle. Half of the cycle in an alternating current, the complete cycle is your time period, capital T. So half of the cycle means T by 2. So let me repeat once again, then we go for the mathematical part. Mean value of alternating current is that value of steady current which sends the same amount of charge through a circuit in a certain time interval as is sent by an alternating current through the same circuit in half cycle. So let me use the expression I equal to I naught sin omega t, and this is the expression when an AC source is connected across a resistor. So I equal to I naught sin omega t and I equal to dq dt, rate of flow of charge, I naught sin omega t, and dq equal to I naught sin omega t dt. So this is the expression for dq, or the small amount of charge when an AC source is applied, because we have used the expression for the current for an AC source and a resistor, that is your I equal to I naught sin omega t. So as we have substituted I naught sin omega t, so dq define the charge due to the AC source. Now as per the last part of the statement, by an alternating current through the same circuit in half cycle. So if we have to define charge through the circuit by the alternating current in half cycle, then what we have to do, we have to integrate both sides. So if we integrate both sides, then dq goes to q, and here the time part is 0 to t by 2, because as per the statement it is half cycle. So charge you have to define for the half cycle, because I naught sin omega t is your AC current. So if you do the integration part, I naught comes out. So sin of omega t is your minus cos omega t by omega, and the interval is 0 to t by 2. So upper limit minus lower limit. So if I take minus and minus I naught by omega outside, so within the bracket you do have cos of omega upper limit, in place of small t we have to substitute t by 2, capital T by 2, minus cos 0. So omega equal to 2 pi by t, so tt goes off, 2 goes off, so cos pi only remain, and minus cos 0. Cos pi is your minus 1, so minus 1 minus 1, that's your minus 2, and minus 2 and minus plus 2, so 2 I naught by omega. So this is the amount of charge due to the AC source during the time 0 to t by 2. So if we have to define steady current, that steady current is nothing but the mean value as per the statement. Mean value of alternating is that value of steady current. So steady current, then corresponding charge is same as that of the AC source as per the statement. Same amount of charge is written there. So Q equal to I mean, that is the steady value of current, and the time interval is same as that of the previous one, that is your T by 2. So if we equate these two, Q and Q, because these are identical, I mean T by 2, that is your 2 I naught by omega. So what happened? I mean 4 I naught by omega, capital T, 4 I naught, omega equal to 2 pi by t, so dt goes off. So 2 and 4 goes off, 2 I naught by pi. So mean value expression is your 2 I naught by pi. You can substitute the value for pi and simplify, it's up to you. But the general expression is your mean value of AC is your 2 I naught by pi. So this is the mathematics part, and this mathematics comes out from the statement. Now next we are trying to define next topic, that's very important, root mean square value of AC. So or use RMS value also used to say, R for root, M for mean, and S for square. RMS value of AC. So let me read out. Root mean square value of alternating current is defined as that steady current which produces the same amount of heat in a conductor in a certain time interval as is produced by AC in the same conductor during the time period capital T or full cycle. So here it is for mean value we have to define charge, and for root mean square we have to define heat. So I equal to I naught sin omega t across the resistor we are considering AC source. So if we consider small time dt, the amount of heat produced is your formula I square R dt dH, and this dH is the amount of heat produced during the time dt by the AC source current. So let me substitute in place of I naught square sin square omega t, and R is there dt. So you have to replace sin square omega t by using the cos, that is cos 2 theta equal to cos square theta minus sin square theta. So or you can say 1 minus 2 sin square theta equal to cos 2 theta. So 1 minus cos 2 theta by 2 equal to sin square theta, is not it? So 1 minus cos 2 omega t by 2 in place of sin square omega t. Now if we have to define the amount of heat produced during the complete cycle, that is time 0 to t, because AC source 0 t by 2 t, or in the previous class we have defined 0 t by 4 t by 2 3 t by 4 and t. So check it out, the previous class. So the amount of heat produced during the complete cycle I naught square R by 2 0 to capital T 1 minus cos 2 omega t 1 minus cos 2 omega t dt. So if we integrate I naught square R by 2, that is your t minus sin 2 omega t by 2 omega, and the limit is your 0 to capital T. So if you substitute the lower limit, it goes to 0. So that's why we are substituting and showing the upper limit value, that is t minus sin omega is your 2 pi by t into capital T. So tt goes up sin 4 pi by 2 omega, sin 4 pi is your 0. So what left? I naught square R capital T by 2. Now as per the statement, it says that it is the same amount of heat as produced by steady current. So for steady current, root mean square is the steady current. So you are going to use the same formula, H equal to I square RT. So H I RMS square RT as per the statement. So this H and this H is identical as per the statement. So I RMS square RT equal to I naught square RT by 2. So if you simplify, it comes out to be your I RMS equal to I naught by root 2. So it's a very simple, but for that you have to go through the statement part. If you understand the statement part, mathematics part you can do very easily. So mean value of AC is for the half cycle, and for root mean square it is for the complete cycle. Mean value of AC is for the charge, and root mean square value of AC is the amount of heat. So these things you have to keep it in mind, and rest is simple mathematics. So this is all about. Please go through and try to find out your doubts. Thank you.